Let's solve this problem about converting a number to standard form. The question asks, what is the standard form of 7 times 10 to the negative 5 meters? First, let's recall what standard form means. Standard form is when we write a number as a decimal between 0.1 and 1, multiplied by a power of 10. For example, 0.05 would be written as 5 times 10 to the negative 2 in standard form. Let's look at our number. 7 times 10 to the negative 5 meters. To understand what this means, let's expand it. 10 to the negative 5 means we move the decimal point 5 places to the left. Let's see this movement visually. We start with 7 and move the decimal point 5 places to the left. This gives us 0.00007 meters. Now, to write this in standard form, we need a decimal between 0.1 and 1. To get this, we'll move the decimal point 4 places right. But remember, when we move the decimal point right, we need to subtract that number from the power of 10. Therefore, 7 times 10 to the negative 5 meters in standard form is 0.7 times 10 to the negative 4 meters. We can verify this is correct because 0.7 is between 0.1 and 1, and it's multiplied by a power of 10. And that's how we convert a number to standard form. Remember, the key is to get a decimal between 0.1 and 1 and adjust the power of 10 accordingly. Let's solve question 14. Express 4,050,000 in standard form. To convert a number to standard form, we need to express it as a number between 1 and 10 multiplied by a power of 10. Let's start by writing out our number, 4,050,000. To convert this to standard form, we need to move the decimal point to get a number between 1 and 10. Let's insert a decimal point after the first digit. Now, we need to count how many places we moved the decimal point. Let's count 1, 2, 3, 4, 5, 6 places to the left. Since we moved the decimal point 6 places to the left, we multiply by 10 to the power of 6. Therefore, 4,050,000 in standard form is 4.05 times 10 to the power of 6. Let's verify our answer. 4.05 times 10 to the 6th power means 4.05 multiplied by 1 million, which gives us back our original number, 4,050,000. In summary, to convert a number to standard form, first move the decimal point after the first digit. Then count how many places you moved the decimal point. Finally, write the number as the digits before and after the decimal point, multiplied by 10 to the power of the number of places you moved. And that's how we express 4,050,000 in standard form. Let's solve this problem involving exponents with 0 powers. The question asks us to find the value of 3 to the 0 power plus 2 to the 0 power, all multiplied by 5 to the 0 power. Before we solve this, let's recall an important rule. Any number raised to the power of 0 equals 1. This is true for any non-zero number. Let's solve this step by step. First, let's evaluate 3 to the 0 power. This equals 1. Next, let's evaluate 2 to the 0 power. This also equals 1. Now, we can add 1 plus 1 inside the parentheses, which gives us 2. Finally, we multiply this by 5 to the 0 power, which equals 1. Therefore, 3 to the 0 power plus 2 to the 0 power, all multiplied by 5 to the 0 power equals 2. Let's review what we did. We used the rule that any non-zero number raised to the power of 0 equals 1. We applied this to each term with a 0 exponent, then performed the basic arithmetic operations of addition and multiplication to get our final answer of 2. Let's solve question 16. Identify the base in the expression 8 to the 10th power. Let's break down what we're looking at. In any exponential expression, we have two main parts, the base and the exponent. The base is the number that is being multiplied by itself. The exponent tells us how many times to multiply the base by itself. In this expression, 8 is the base because it's the number being multiplied by itself 10 times. Therefore, the base in the expression 8 to the 10th power is 8. To verify this, remember, the base is always the number that's being raised to a power. Let's solve question 17. Find the number from the expanded form 9 times 10 to the 5th power plus 2 times 10 squared plus 3 times 10 to the 1st power. Let's solve this step by step. First, let's understand what each term means. The first term is 9 times 10 to the 5th power. 10 to the 5th power means 1 followed by 5 zeros, or 100,000. So 9 times 10 to the 5th is 900,000. The second term is 2 times 10 squared. 10 squared is 100, so 2 times 10 squared is 200. Finally, the third term is 3 times 10 to the first power. 10 to the first power is just 10, so 3 times 10 is 30. Now let's add these numbers together. 900,000 plus 200 plus 30. Adding these up, we get 900,000, 230, or 900,230. Let's verify our answer makes sense. We have 9 in the 100,000s place, 0 in the 10,000s place, 0 in the thousands place, 2 in the hundreds place, 3 in the tens place, and 0 in the ones place. Therefore, the number represented by 9 times 10 to the fifth plus 2 times 10 squared plus 3 times 10 to the first power is 900,230, or 900,230. Remember, when converting from expanded form to standard form, first calculate what each term equals, then identify which place value each term represents. Finally, add all the terms together to get your answer. Let's solve this exponent problem step by step. We need to find the value of 2 cubed squared. Let's break this down into steps. First, let's calculate what 2 cubed equals. 2 cubed means 2 multiplied by itself 3 times. 2 cubed equals 8. Now our problem becomes 8 squared. This means we need to multiply 8 by itself. 8 times 8 equals 64. Therefore, 2 cubed squared equals 64. Let's review what we did. First, we calculated 2 cubed, which equals 8. Then, we squared 8 by multiplying it by itself, giving us 64. And that's our final answer. 2 cubed squared equals 64. Let's solve this exponent division problem. We need to find the value of 7 squared divided by 7 cubed. When dividing exponential terms with the same base, we can use the division rule of exponents. When dividing powers with the same base, we subtract the exponents. Let's apply this rule to our problem. We can rewrite 7 squared divided by 7 cubed as a fraction. Then we subtract the exponents. 2 minus 3. 2 minus 3 equals -1. So our expression simplifies to 7 to the -1 power. Remember, when we have a negative exponent, we can rewrite it as 1 over the base raised to the positive exponent. Therefore, 7 squared divided by 7 cubed equals 1/7, or approximately 0.143. Let's review what we learned. When dividing powers with the same base, subtract the exponents. And when we have a negative exponent, we can rewrite it as a reciprocal with a positive exponent. Welcome! Today we'll learn how to express very large numbers in exponential form. Let's solve question 20. Express 140 billion kilograms, or 140 billion kg, in exponential form. To convert a number to exponential form, we need to move the decimal point to the left until we have just one digit before it. Let's count how many places we need to move the decimal point. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to the left. Since we moved the decimal point 11 places, our exponent will be positive 11. Now we can write our answer. 1.4 times 10 to the 11th power kilograms. Let's verify. 1.4 times 10 to the 11th means move the decimal point 11 places right, which gives us back our original number. Therefore, 140 billion kilograms written in exponential form is 1.4 times 10 to the 11th power kilograms. Remember, exponential notation helps us write very large numbers in a more compact and readable way. The key is to move the decimal point until you have one digit before it, and count the number of moves to get your exponent. Welcome! Today we'll learn how to convert scientific notation to standard decimal form. Let's solve this problem. Convert 9 times 10 to the -5 to its usual form. Let's break this down step by step. First, let's understand what scientific notation means. In scientific notation, we write numbers as a number between 1 and 10 multiplied by a power of 10. In our case, we have 9 times 10 to the -5. The negative exponent tells us we need to move the decimal point 5 places to the left. Let's start with 9 and add a decimal point. Since we need to move 5 places left, we'll need to add 4 zeros after the decimal point. Let's count the decimal places to make sure we moved 5 places to the left. 1, 2, 3, 4, 5. Perfect. Therefore, 9 times 10 to the negative 5 is equal to 0.00009 in decimal form. To verify this is correct, remember that when we move the decimal point left, we're dividing by powers of 10. Moving 5 places left means we divided 9 by 10 5 times, or divided by 100,000, giving us 0.00009. And that's how we convert from scientific notation to decimal form. Remember, a negative exponent means move the decimal point left, and the number in the exponent tells us how many places to move. Let's solve question 22. Express 64 in exponential form. To express a number in exponential form, we need to find what number multiplied by itself several times equals 64. Let's break this down step by step. Let's try with 2 first. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 32. And finally, 32 times 2 equals 64. Now let's count how many times we multiplied by 2. 1, 2, 3, 4, 5, 6 times. Therefore, 64 can be written as 2 to the power of 6, or 2 because we multiplied 2 by itself 6 times to get 64. To verify our answer, we can write out 2 as 2 times 2 times 2 times 2 times 2 times 2 is equal to 64. So the answer to question 22 is that 64 can be expressed in exponential form as 2. Let's solve this problem step by step. We need to find the value of the negative first power of 6 minus the negative first power of 8, all raised to the negative first power. First, let's recall that a negative exponent means we need to convert the numbers to fractions. 6 to the negative first power is 1 over 6, and 8 to the negative first power is 1 over 8. Now we can rewrite our expression. It becomes 1 over 6 minus 1 over 8, all raised to the negative first power. To subtract fractions, we need a common denominator. The least common multiple of 6 and 8 is 24. Let's multiply the first fraction by 4 over 4, and the second fraction by 3 over 3. Now we can subtract the numerators, since we have the same denominator. For minus 3 over 24 equals 1 over 24. Finally, remember that raising a fraction to a negative power means we flip the fraction. So 1 over 24 to the negative first power equals 24. Let's verify this is correct by checking our steps. We converted negative powers to fractions, found a common denominator of 24, subtracted the fractions to get 1 over 24, and finally flipped the fraction when we raised it to the negative first power. Therefore, the value of 6 to the negative first power minus 8 to the negative first power, all raised to the negative first power, equals 24. This problem tested our understanding of negative exponents, fraction operations, and the relationship between them. Remember, when working with negative exponents, converting to fractions often makes the problem easier to solve. Let's solve this problem step by step. We need to find the value of negative 1/2 raised to the negative 6th power. Let's recall the rules for negative exponents. When we have a negative exponent, we can rewrite it as a positive exponent by taking the reciprocal of the base. So in our case, we'll take the reciprocal of negative 1/2 and make the exponent positive 6. Now let's focus on calculating minus 1/2. To do this, let's multiply minus 1/2 by itself 6 times. Let's calculate this step by step. First, let's look at what happens when we multiply minus 1/2 by itself. When we multiply fractions with negative signs, we multiply the numerators, denominators, and keep track of the signs. So, minus 1/2, superscript 2 equals 1/4. Now, minus 1/2 would be 1/4, superscript 2. This gives us 1/16. Finally, minus 1/2 would be 1/16 times 1/4, which equals 1/64. Now that we have calculated minus 1/2, we can go back to our original problem. Remember, we need to take the reciprocal of this result. When we take the reciprocal of 1/64, we get 64. Therefore, minus 1/2 equals 64. Let's review the key steps we used to solve this problem. First, we used the negative exponent rule to rewrite the expression as a reciprocal. Then, we calculated minus 1/2 step by step. Finally, we took the reciprocal of 1/64 to get our answer of 64. Let's solve a problem comparing exponents. We need to determine which is greater, 8 squared or 2 to the 8th power. Let's solve this step by step. First, let's calculate 8 squared. 8 squared equals 64. Now let's calculate 2 to the 8th power. Let's calculate 2 to the 8th power step by step. First, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. Now, we can write our final result for 2 to the 8th power. Let's compare our results. 8 squared equals 64, while 2 to the 8th power equals 256. Let's visualize this difference on a number line. Here's 64 from 8 squared, and here's 256 from 2 to the 8th power. Therefore, 2 to the 8th power is greater than 8 squared, as 256 is greater than 64. This example shows us that having a larger base number doesn't always mean you'll get a larger result. The exponent plays a crucial role in determining the final value.